Guys, I hope you all are good and doing well for the preparation of your CIEs. Guys, the topic here I'm going to solve for you, that is the test 3 I took as a bi-monthly, and the topics from which the question comes, that is functions and coordinate geometry. The first question says show that the curve with the equation x minus 3xy minus 40 is equal to 0 and the line 3x plus y plus k equal to 0 meet for all values of k. So here you are given curve x minus 3xy minus 40 equal to 0 and the line, that is 3x plus y plus k equal to 0. It is given that these two will meet for all values of k. So we have to show this. So we can suppose this is equation number 1 and this is equation number 2. First of all, whenever you keep this word meet, intersect, cross, right, so that means you need to solve them simultaneously to get a quadratic equation, and then we will apply some certain properties. So here from equation number 2, if I can make y as a subject, it will be minus y equal to minus 3x minus k. So now do replace this result in 1. We get x minus 3 times x and minus 3x minus k minus 40 equal to 0. So x square plus 9x square plus 3kx minus 40 equal to 0. So it's x, right? X plus 9x square, this was x. So further 9x square, and from this term and this term we can take x as a common, and we can write it as 3k plus 1 times x minus 40 equal to 0. As it is clear in the question, I have highlighted with the the yellow color, that it will exist meet for all values of constant k. So for all real values of k, no matter positive or negative, so we can apply the discriminant property, b square minus 4ac must be greater than or equal for real for all values greater than equal to 0. Here we can see 3k plus 1 whole square minus 4 times of a times of c is greater than equal to 0. We can say 3k plus 1 whole square is plus minus 1 plus 1440. So that is true. Meaning for all value, whatever the values of k, you will replace here, because no matter is negative, positive, rational, irrational, but because of square you will get the positive result, and your result will always be bigger than 0. So hence, which shows, which is true for all values of k. Hence proved. We have to, for all values k, your result will be bigger than 0. So hence we have proved this, which is true for all values k. Done. Next question. The function f is defined by this: x belongs to real number. Express f of x in the term of a minus b times x minus c whole square, where a, b, c are constant. Shows the range of the function. Okay. Here you can see the function we need to convert in this form, whole square form, that means completing square form. So we can write it as f of x is equal to 3 minus 2x square plus 6x. So if we can take common minus 2 from here, x square minus 3x, we get it. Now within the bracket, here we can make the completing square pattern. So as you know well, in the previous video we have discussed how to go for the completing square approach to convert the given quadratic equation or expression in a completing square form. We already have done that. So accordingly, half of 3 is what? 3 by 2 or 1.5. No matter, you can write in decimal or in fraction as well. B square minus and 3 by 2 half by 2 whole square will be added and subtracted from this expression. We get 3 minus 2, and you know our first three terms will be changed into x minus 3 by 2 whole square is equal to 9 by 4. Now 2 can be multiplied because we need to convert this given expression in this form, which is going to be asked as a completing square form. So 2 into x minus 3 by 2 whole square minus minus plus 9 by 2. So now here you can solve this 3 and plus 9 by 2. It will be 2 with LCM. 6 plus 9 is 15 by 2 minus 2 into x minus 3 by 2 whole square, which you can see is the required form which is going to be asked. And we can write which is the required form with a is what 15 by 2, b is what b is 2, and c is 3 by 2. I hope it is clear. And now we have to also do one more thing with this question, and state the range of f. You can see this figure, this given expression, that is quadratic expression, and here the coefficient of x square is negative, so it says a is negative. And if you can sketch the figure, it will be roughly sketch. I'm doing it. Its vertex are 3 by 2 and 15. 3 by 2, say 3 by 2 is lying here. From here I got the vertex point, and 15 is suppose 15 by 2 is here. 15 by 2, that is 7.5, right? On y-axis. So the figure will be like, sad face will be like this, and it will cross from x-axis at certain points. We are not behind that point, so you need to know it. This is the vertex point, that is 3 by 2 and 15 by 2, yani 1.5 and 7.5 other sense you can say. This is axis, that is y, and here it was. Okay, so it's very much clear from here. Your range is of the function in y value is less than 15 by 2, so you can say range of f of x will be like here. F of x is less than or equal to 15 by 2, the y coordinates. So that is the answer. I hope it is clear. B part of this question. The graph of y equal to f of x is transformed to the graph of y equal to h of x. We wrote this as f of x as that is 15 by 2. We have converted that into completing square form, x minus 3 by 2, where in the figure it was clear. You have the vertex 3 by 2 and 15 by 2. It is given that transformed to the y equal to h of x, by reflection in one of the axes followed by the translation. Okay, first is reflection. So as this reflection takes reflection along x-axis, so in one of the axes. Okay, so and what else is given? It is given that the y h of x has a minimum point at the origin. So minimum point at the origin, we must get the minimum point. So here minimum point, we can see here in the figure. If you can see the figure, maximum point, roughly sketch again. I can do this. Okay, let me change the color. Yes, here it will be vertex point is 3 by 2 and 15 by 2, and this is the maximum point. I can say this is the maximum point on which we have 15 by 2, and rest will be we are looking for the minimum point. So minimum point goes between towards below x-axis. Okay, so we can say for the minimum point we will take the reflection in the x-axis. So we will take a reflection in the x-axis because here it has maximum point. So minimum point will be like this. It should be, somewhere like this. So this is a minimum point. So we can take the reflection in the x-axis. So for the x-axis we know what to do. Y, that means y should be minus f of x. So we will get what we will get. Y h of x will be minus 15 by 2 plus 2 time of x minus 3 by 2 whole square, right? In this maximum minimum concept we got it because given reflection is one of the axes followed by translation, and it is given graph has minimum value at the origin. Okay, at the origin. So we have this thing now. Reflection we done in the x-axis. So now the vertex will be 3 by 2 and minus 15 by 2 for the minimum. Okay, now it's said that after reflection followed by a translation. Okay, because it's going to be in the minimum point at the origin, and then it means it needs to be this way, translation followed by a translation, so that minimum point comes to be at the origin. So now for the second case of translation, you can translate. Now you translate y equal to h of x above function or graph, so that the vertex, your vertex moves at O origin 0 0. So for that it means x and y become 0. So we can say y will be here. I can change the color to highlight this final case. Y will be, it means it can be translated with the negative of this. X will change, goes from here to here. Y will be translated with minus 3 by 2 and column factor 15 by 2. We can say this is the case study, and that needs to be discussed. With this case of 2 marks, it's little tricky, but I hope you got it. What to do? First you need to reflect it, and as we reflect it, then you need to translate it so that the minimum points come at origin, right? So you will move this minus 15 from here, minus 15 we need to bring it here 0, and minus 3 by 2 need to translate towards here, and this goes up minus 15 by 2. That's why we say that at the origin the translation will be minus 3 by 2, because you need to switch this dotted minimum point at the origin. I hope it is clear. It's a bit tricky, but interesting question. C part, the function the same in the part 1, g of x. Now we have already we know this. We have converted that into other forms, 2 marks again. Okay, what to do? It is 3 plus 6x minus 2x square. For the domain is x is less than equal to 0. Okay, this is very much important point. Sketch the graph of y equal to g of x and explain why g is 1 function. You are not required to find the coordinates of any intersection of the axes. Okay, just simply you can say here coordinate of the intersection of the axis, no need. So 1 marks for the here to write why it is g is 1 and other one is to sketch, roughly sketch. Generally in the part already we have done that 3. It can be written as 15 by 2 minus 2 time of x minus 3 by 2 whole square. So vertex will be here, suppose, and it will cross like this. And here is a point 3 because this is y intersect for this case, right? Generally if you can draw the same with here, the curve will be like this. This will be 3, and the same you can go with this. Okay, anyhow, that is not as much important because sketch is going to be asked for the part C. So, and it is going to be roughly sketched as well. So here I do this just a rough sketch. The condition, what is very much important, that x must be less than equal to 0. So it means this is much more important for us to this line. The red line is important because we are not interested with the blue one that has the vertex 3 by 2 and 15 by 2. We are not interested with it. Only we are looking for the red one because your domain is x is less than equal to 0. That was a simple sketch of and why it is not. Yes, if you go with the red one, we can say only part of the graph. You can say only for x is less than equal to 0 given domain, only part of the graph that is that is, you can say x is less than equal to 0, red one, right? Any red one is required. And because it has it can keep its inverse, and for 1 since inverse of g of x is possible, because we know this easy, you can find inverse can possible only when the function is 1 so that's why possible. So g is 1 1 mark for this and 1 mark for this. A rough sketch of red line. I hope it is clear. Okay, still we have D part. Interesting. So now it says the graph of y equal to g of x, g inverse of x on your diagram in C. We need to sketch this. Okay, not leaving us, this is y-axis. This is 4 marks question. So here you can even solve for the for the axis as well, x intercept, y intercept. It is given the y, sketch the y is equal to any g of inverse of x. Y equal to g of x, we know that was 15 by 2 minus 2 into x minus 3 by 2 whole square for x is less than equal to 0. So graph will be from starting from 3, it will be like this, right? Okay. And we need to sketch it against g inverse of x. For g inverse of x, find an expression for g inverse of x. We need to find expression as well, and that's why it keeps up 4 marks. And label the two diagram in your diagram appropriately and show any relevant mirrored line. Mirrored line between the f of x and g of x, that is always mirror line for the function and its inverse is always be a line which is y equal to x. This must be the mirror line for all cases whenever you will have this case to draw function and its inverse on the same. There will be always a mirror line that must be y equal to x. So that is a mirror line, blue one, I drew it. And now as you can see, just keep a few points that here must be a turning point. This is the graph. Here it is 0 and 3 for g of x. So for inverse function it will be 3 and 0. 3 and because the domain become range and range become domain for the inverse function, we already have done this, and it will be like this. Okay. This is the shape of the graph. Okay, let me make it more precise. Okay, sorry. Here if I can say this is 3 0, and it will be, this will be g inverse of x when this red one is g of x, and this blue one is the mirror line that defines. Now only thing we need to find the expression is given. Find an expression of g inverse of x that keeps its marks. From here g inverse y equal to 15. Make here x as a subject as per rule defined, so we can get this simple way. 15 by 2 minus y will be 2 times of x minus 3 by 2 whole square. You know the technique how to make subject, so divide by 2 first. It will be x minus 3 by 2 whole square is equal to 15 by 4 minus y by 2. Now take square root. X minus 3 by 2 will be plus and minus square root 15 by 4 minus y by 2. So x will be 3 by 2 plus and minus, I can take the LCM, 15 minus 2y, 4 was the LCM, so divided by 2. Or x will be 3 by 3 plus minus 15 minus 2y by 2. So as given function keeps its domain less than or equal to 0, so it can be true when this other function in the search or in the root will be negative. So I can say x, final answer is x is equal to 3 minus, you're gonna g inverse of x. G inverse of x is 3 minus 15 minus 2x over 2. That is the expression, and along with the expression we have drawn the graph as well. So this is a 4-mark question. I hope it is very much clear. The graph and of g and g inverse and mirror line. This I can write it mirror line. Mirror line. It will always be y equal to x. Okay. Here now the question number 3 states The function f is defined by f of x is 2x plus 1 over 2x minus 1 for x is less than 1 by 2. State the value of f of minus 1. So f of minus 1, do replace x with minus 1. We will get the answer 2 into minus 1 minus 1. It will be minus 1 by minus 3. So I can write this is equal to 1 by 3, 1 marks question. I hope it's clear. Very easy. Now part 2 of the question. The diagram shows the graph of y equal to f of x. Okay, that graph is given. This is y equal to f of x graph already given to us. Okay, sketch the graph of f inverse on this diagram. Show any relevant mirror line. Again mirror line. So mirror line, you know that will be y equal to x. I can draw this line by this. This is y equal to x, the mirror line as defined above. A 2 marks question, so we need to just sketch it. Here this coordinate is very much clear. This is x is minus 4 and y is supposed to be 1, so 0 say 8. Okay, and here it will be 0.2 and minus 4. So for the inverse function we just need to swap the coordinates. Domain become range and range become domain. So here minus 4, so it means it becomes this minus 4 and 0.8 coordinates for f of x, and other we marked 0.2 and minus 4. That will change for f inverse of x. It will be we are changing from it, so it will be 0.8 and minus 4, and this comes to be minus 4 and 0.2. Okay, first one is 0.8. Suppose it is this is 1, 0 point is here, it comes here, and minus 4. Okay, fine. 1 point is this, other is minus 4 and 0.2 this, and definitely it must keep this intersecting point. So the graph will be like this. This will be the quick graph of given function from f of x to f inverse of x. 2 marks. Mirror line already we have drawn, so I hope it is very much clear. Okay, now the final third part of this question is find an expression of f inverse of x and state a domain of f inverse. Dome of f inverse is equal to what? Range of f. We know this rule, and similarly domain range of f inverse will be the domain of f. So let's solve it. You are given f of x as 2x plus 1 over 2x minus 1, 2x plus 1 over 2x minus 1. So this is y, cross multiply 2xy minus y equal to 2x plus 1, bring all x one side and y on other side. 2xy minus 2x is equal to y plus 1. X is common now. 2y minus 2 equal to y plus 1. X will be y plus 1 over, either you can write 2 common as 2y minus 1, or let it be 2y minus 2. It doesn't affect it. So here you can see, now you need to find the inverse, and that is the range of f. Okay, now it's also given the function g of x is this. For x belongs to real number, solve the equation f of x is g f of 1 by 4. Already we are given in the first part, that is 2x plus 1 over 2x minus 1. You are given this. So first find f of 1 by 4. 2 times 1 by 4 plus 1 over 2 times 1 by 4 minus 1. You can simplify on the even calculator, or you will get f of 1 by 4 is equal to 1 by 2 plus 3 by 2, and 1 by 2, that is 3. You can solve it by yourself, or either no problem on it's minus 3, sorry. On the calculator you will get this, f of 1 by 4 is minus 3. So it means now g f of 1 by 4 becomes g of minus 3, because this whole answer is minus 3. Now g of x is given to be 3x plus 2. So g of minus 3 will be what? 3 times minus 3 plus 2, that will be minus 9 plus 2 is minus 7. Now we have to solve. F of x, it means this is what? G f of 1 by 4, that is minus 7. We have done this. Right hand side equal to minus 7. Now f of x is equal to 2x plus 1 over 2x minus 1, that is given to be minus 7. Simplify it, cross multiply. 2x plus 1 equal to minus 14x plus 7. So minus 14 becomes here and 1 goes there, is 16x equal to 6. X will be 3, 2 3s are 2 8s are 3 by 8. I hope it is clear. X is 3 by 8. That is the solution of this given expression. The 3 marks as well. Okay, here the questions number 4. It said the diagram shows a curve with equation this and this, two curves with this. Find the x coordinates of the points of intersection of the curves. Okay, our intersection, cross, meet, that means you need to solve simultaneously. So do compare the y coordinates of both, as we are looking for x. So I can write x cube, 2x cube minus 4x square plus 3 equal to x cube minus 3x plus 3. So bring all terms one side, 2x cube minus x square minus 4x square minus 3x plus 3 and minus 3 equal to 0. This goes. So we have x square minus 4x square minus 3x equal to 0. So this is x cube first term. This was x cube, right? Because this x cube comes here, x cube. Now we can take x as a common. We can write x square minus 4x minus 3 equal to 0. Further we can make the factor. It will be x minus 3 and x plus 1. Yeah, let me check. This is minus 3 comes here to becomes plus 3. So it will be plus 3 plus. So sorry, or yes, I hope now you got it. So x minus 3 and x minus 1 will be the factor of this, and this is 0. So we have factorized the terms, so it will be this. So what comes 1 time x 0, one solution is here. You can see x is 0, right? Then x minus 1 0, so x will be 1. So here it can be 1. Okay, and x minus 3 equal to 0, x will be 3. So you can see here it can be x can be here 3, because if it's 1 then it can be 2 here somewhere, and then 3 will be. So 4 marks question, very easy question. Okay, just need to do some calculations. The 5th question, and I think this is the final question. Okay, final question says point A and B have coordinates 4 3 and 8 minus 5 respectively. A circle with radius 10 passes through the points A B. It means if this is a circle and A B, so A, if it is 4 3, say A is here, 4 and 3, and B is 8 and minus 5. Suppose B is lying here, 8 and minus 5. Okay, no problem. Anyway, it's a rough sketch, not on the exact accurate sketch. Just want to decide how can we show that the center of the circle lie on this line. It means we need to find a line. So very much clear. We know if we can join these 2 points, given points, so then it makes a chord. And we know the property of a circle that the line right from the center to any of a circle to any chord bisects the chord. So it means this portion is the same as this. This is M midpoint. So midpoint of AB will be that is 4 plus 8 by 2, comma 3 minus 5 by 2, and it will be midpoint will be 6 and minus 1, right? This is the midpoint on which we need to show the center of circle lies on this line. Okay, we need to find this line as well. So, and radius, we are given the radius, that is 10, right? AC or AB is the same, that is 10. So we can see as AC and CM, AB is perpendicular to CM, so gradient of AB, M of AB will be, we can find it, y2 minus y1 over x2 minus x1. The rule we know well. It will be given the formula sheet. 8 by minus 4, it will be minus 2. So gradient of CM will be negative reciprocal of it. It will be 1 by 2. Therefore, equation of line CM passes through M, that is 6 and minus 1, with gradient 1 by 2, and it says that it must be this one, which we have to prove. So is y minus y1, y minus y1 equal to M times x minus x1. So y plus 1 equal to 1 by 2 times x minus 6. As we have to solve this, y plus 1 is equal to x by 2 minus 3. So if you take this one on the other side, y will be x1 by 2x minus 3, and minus 1 makes minus 4. So it means this line, this is CM, must be the line which must pass through the center of the circle. So this is a simple question, so not as difficult as seem to be. So that's the answer. I hope everyone is cleared about this test, and there is no more question left. Okay, almost every question has done. The function question about the graph, you need to be very careful, especially I can put the star here. This question is very interesting and very challenging question, because you need to focus on the statement. If little you are out of the focus of the statement, that means you will do it wrong. Okay, good luck. Keep watching the videos and make more understanding and learn more from the books, and do maximum question from the past year papers to get good grip on the topics. Good luck, guys.